Hello, in today's video we're going to introduce tangent line and instantaneous velocity. So first, let me show you what is a tangent line. So in this given graph, you will see a black dashed line and the function is in the red line. So look at this graph as I changing the dashed line, what happened? What do they have in common, all of these black lines? First of all, they could be in different position, right? That means a tangent line, a function may have infinite many tangent lines. Secondly, what do you find out about each tangent line? Well, if you look carefully, you might find out that, hey, tangent line only intersect with the function with one point, right? So basically, if this point is here, we will say, hey, this is the tangent line for the function at -2 and -2. All right, so what if the function intersect? What if there's a line intersect with the function with two dots, like this one? So what do we call this? So the green line, as we show in here, let me get rid of the black one. We call the green line is secant line. Basically, it's the line intercept at a given point, intercept the function more than once, I'm sorry. So for example, especially at the point -2 and -2. So if we try to find tangent line, this is not the tangent line for the -2 and -2. But this black dashed line is going to be the tangent line for the function at the point -2 and 2. So it has to be -2 and -2. This has to be the specific point. Okay, so what is the application of tangent line? Okay, so imagine that you are, let me use a green pen. You are living on a hill. This is your house. And in the morning, you decided to take a run. This is your routine. You like to take a run in the morning. And then your route is you're going down first and cross the bottom and go back up and going down again to go back to your house. This is your route. You're starting from here. Okay, so think about it. This route is totally 5 miles. And then you spend an hour to finish the trail. So that means your average speed is what? 5 miles per hour. However, we know that this is not your instantaneous speed, because at instantaneous speed, you're going to sometimes you run faster and sometimes you get slower. Such as when you first beginning, at this point, you just woke up, you haven't warmed up yet, you're just warming up. So probably this is 3 miles per hour. And when you get to this point, you're starting to feel very good. You're already totally warm up and it's flat. You're running maybe 6 miles or 7 miles per hour. And then now at beginning, when you're going up, you're still good. You're still doing 5.5 miles per hour. But when get to this point, you're already feeling really tired because you climb all the way to the mountains. You're probably doing 2 miles per hour. In the last section, it's going downhill, you feel good, and you just can't wait to go home and take a nice hot bath or shower. You're running super fast. You're doing 8 miles per hour. So at any of this given point, this is going to be your instantaneous speed. Basically, it's like when you're driving, when you see the dashboard, your speed is changing all the time. So this is called instantaneous speed. So as you can see, the instantaneous speed, they don't have to be the same as the average speed. They can be the same, but not necessary. So now, how do we find the instantaneous speed? Well, if you're running from point A to point B, and your speed change all the time, right? You are starting with 5 miles and suddenly you become 6 miles. At here, you are 7 or 8 miles. So per hour. So how do you do it? Well, the best way to do it is to find out the short distance here as short as possible. Then you will get a more precise calculation. You find out the distance between this section and the time that you spend at this section, which is, like say, maybe this is you're starting running at 9 o'clock and you finish at 10 o'clock. And then you want to calculate the speed at from 10:15 to 10:16, 1 minute. And then given the distance that you run, maybe, I don't know, maybe 0.02 miles, then will give you an instant speed. So how can I be more accurate? Maybe I narrow it down to seconds. Maybe if I try to calculate, hey, 13 seconds, the changing time is 13 seconds, and given the changing distance within that time, that will give you a more accurate instantaneous speed. But if we're getting smaller and smaller, we will end up to get 0/0, which means it may make no sense. So in this case, what we can use is the tangent line. So think about, here's you running. The x-axis is the time that you spend. You're starting at 9 o'clock and ends at 10 o'clock. And then this is the distance that you run in miles. This is 1 mile, 2 miles, and totally it's 5 miles. Again, at beginning, you may go very slow because you're just waking up. And then later, you feel good. You're going faster in a shorter amount of time. And then when it comes to uphill, you slow down again. And then at the end, you go really fast. So maybe the graph of your running is something like that in terms of the distance versus the time. So for instantaneous speed, it's going to be at any given point, you're finding the tangent line at this given point, and then the slope of the tangent line is going to be your instantaneous speed. So what is an instantaneous velocity? So instantaneous velocity, the difference between speed and the velocity is speed, they don't have direction. Velocity is more like a physics concept. Velocity has direction. Let's say your direction is always running towards home, so it's positive direction. So your velocity is going to be a positive. Even though you see a negative velocity, doesn't mean you are not running. That means you're running towards the other direction. Maybe you're running away from home. Okay, so that's the tangent line. So in the later chapter, I'm going to teach you how to find the slope of a given point's tangent line. So here's an example. So the graph y equal to gx, at what value s does the graph of g of x below have a horizontal tangent line? A horizontal tangent line is a line that parallel to the x-axis. What do you think? So I'm going to give you a random graph similar enough to that one. The graph look like this one. So what do you think, at what point this is going to have a horizontal tangent line? Make a guess. It's going to add the maximum, the local maximum, or the local minimum, right? At this point, here you will have a horizontal tangent line, because at the peak, you're not going to, if you have a horizontal line, you're not going to intercept with other graph at that point. Okay, so this is just an introductory video. In later, we're going to explore more about what is the instantaneous speed and velocity. See you next time.